back. We're going to look at some examples of how to find extrema here. I'm just going to pull some problems right out of the book. I'm looking on page 169. I'll go through the 19 to 34, your comfort level section there. And I guess we'll just pick a problem here at random. I guess I'll do an even one since you guys can check your odds yourself. And we'll jump down to like number 24 right off the bat. 24 is f of x equals x cubed minus 12x, and you're given a closed interval from 0 to 4. So right off the bat, closed interval, I need to test these guys. These are my a and b values. So I'm going to have to test f of 0, and I'm going to have to test f of 4. And you know what? Since I'm writing them, I might as well knock them out. F of 0 is 0. And f of 4 cubed is 64. 64 minus 48, we're looking at 16. Okay, so now we got to take the derivative and set it equal to 0 to find the rest of our critical numbers. So that is going to equal 0. I can take a 3 out of there and get x squared minus 4. So I have two solutions of x equals plus or minus 2. However, keep in mind that our interval is 0 to 4, so I don't care about the negative 2. I just care about the 2. When I plug a 2 into the function, I get 8 minus 24. That's a negative 16. So I look at these guys and I say, which one's the biggest? Well, this is the biggest. F of 4 is 16. Okay, so that is my absolute maximum. And I look at my lowest, and this is my absolute minimum. Okay, and that means, not that they're asking for it, but this would be a relative minimum. Actually, it's a relative extrema. Let me backtrack what I just said there. We don't know if it's a min or a max. We don't know what the graph is doing at that point yet. So we'll just call it a relative extreme for now. But again, that's why they're just asking you for absolute extrema right now. We're not quite at the stage where we can determine what kind of relative extreme it is. Let's take a gander here at something like number 30. 30 is h of t equals t over t minus 2. And we are on the interval from 3 to 5. And that's convenient, closed interval there. I say that's convenient because 2 is an issue. 2 would be a point of non-differentiability. Okay, but 2 is not in an interval, so we don't need to worry about it. But let's try these guys out a while. H of 3, if I plugged in, I get 3 over 1 is 3. And h of 5 looks like it'll be 5/3. It's deriving time. So derivative, this is going to be a nice little quotient rule here for us. G, f prime is boring, that's 1, minus f, g prime is just as boring, also 1, all over g squared. So let's simplify it so we can solve it a little bit. T minus 2 minus t is, that's just going to be a minus 2 there, it looks like, right? Over t minus 2 squared. All right, so critical numbers, we don't have any critical numbers because this will never be equal to 0. All right, it does have an undefined moment at 2, but that's not in our interval. All right, so I'm going to check my derivative here, t minus t. Yep, we're good. So this guy right here, 3 is the highest. That's the absolute max. And this is the absolute min. And we are done with that. So now I'm just going to show you here on the calculator just so we can confirm these answers. What these look like on the calculator, so you can see that an absolute max is at the top of a hill, where an absolute min is at the bottom of a valley, if you will, or a gully. And then we could actually, by looking at the graph, determine up here if f of 0 is a relative max or relative min pretty easily just by looking at the graph. So let's throw our y equals in there. It was x cubed minus 12x, x cubed minus 12x. Oh, don't need that up in the exponents there. X cubed minus 12x. And we're going on a window from 0 to 4 was what we were given. So let's go like negative 4 to 8 to give ourselves some wiggle room. 0, and our maximum, if I recall over here, was 16 and negative 16. So I'm going to go negative 20 to 20. I want to make sure we can see everything. So here's our graph from 0 to 4. Why is there a scale on here? Scale is 0. Let's do a scale of 1. graph. Let's drag this guy right onto here. We can look at him. And, all right, and I'm going over the top here now, but that's okay. So 1, 2, 3, 4, we're up here. Yep, looks like a 16-ish in that area. All right, so 4 puts us here. F of 4 equals 16. And we're at 0 here. So 2 is right here, and that's at negative 16. F of 2 is negative 16. All right, so this one, since it's a closed interval, is it's a little technicality there. Some people will call that a relative max. Others will say it's nothing, but because the graph does continue. But they're looking at just this interval here. So again, we're only looking for the absolute max and absolute mins here. So that's what we're going to stick with. And you can do a similar thing to test your answers for h of t. All right, so those are 2 examples on finding relative extrema. We'll catch you later.